Good morning and good day to all audience and viewer from Masa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Work Environment and Information Technology of Masa University. My name is Siti Shahira binti Saidin, Masa University lecturer, and I will be serving as your moderator today. Today, we'll be hearing a presentation from Ms. Nurhafiza Habidin. Ms. Nurhafiza Hafidin received a degree in Mechanical Engineering from National University of Malaysia, Selangor in 2007 and a Master degree in Mechanical Engineering from National University of Malaysia, Selangor. Since 2019, she has been a lecturer with School of Engineering in the International College Penang and currently works as Head of Program for Mechanical Engineering. Her research interests include thermodynamics and fluid mechanics. Without further ado, I would like to welcome Ms. Nur Hafiza, who will be speaking to us with topic Otto cycle versus diesel cycle for power generations. Alright, Ms. Nur Hafiza, the floor is yours.
Thank you, Dr. Shahira. Assalamualaikum and good morning, everyone. So I am Nur Hafiza. Currently, just a little bit background on myself. I am currently working as a head of program for mechanical engineering. So here in INTI International College Penang, we have diploma in mechanical engineering and also bachelor in mechanical engineering. So I'm taking care of these two programs. I also have been a lecturer for more than 5 years already. And as mentioned by Dr. Shahira, I have gotten my degree from UKM in mechanical engineering in 2017 and also my master also in UKM in 2018, both in mechanical engineering. And my research interests are on thermofluid, especially on the engine. So I'm working on basically mostly on the petrol engine and also diesel engine. Okay, to start with the title of the Otto cycle versus diesel cycle for power generation, let me share my screen. Yeah. Are you able to see my screen? Can see my screen?
Yes, I can see now.
Okay. All right. So today the topics that I will present is Otto cycle versus diesel cycle for power generation. Perhaps to give you a brief view, on the power generation, most of it, electrics are being generated through a power plant. And there are many kinds of power plant. So we will look into thermal power plant. So throughout globally, we have quite a number of power plant around the globe. One of it we have Williamson Energy from America. We also have locally our own power plant, which is Sultan Iskandar Power Station. So Sultan Iskandar Power Station is in Johor Bahru. So throughout, there are so many kinds of power plant we have in total. And in Malaysia itself, we have many power plants that working on different cycles. So some of it working on the open cycle, closed cycle, auto cycle, diesel cycle, and many more. So for the power station that we have also, we also there are many types such as hydro power plant, we have biomass power plant, we have natural gases power plant also. So overall, is if we look into the power plant, there are many kind, many variations. There are many cycles are being combined in a one power plant. So let me go through in terms of the working mechanism, the basic working mechanism. So this one is an example of basic mechanism of a steam power plant. So in a steam power plant, basically it comprises of four devices. Okay, we start with this is basically the basic pump. That it will have much more devices, but it start with pump. So pump, the function of pump is to increase pressure, and pump need input work in order for it to be work. So the function of pump here is to increase pressure from the normal temperature and normal pressure of working fluid that we have. And after it has been compressed to increase the pressure, it will then enter the boiler. So the function of boiler, it act as an energy source in which similar concept like we have kettle at our home, we want to boil, right? We want to boil to a higher temperature and pressure. Same concept in a thermal power plant where we need boiler to for the combustions to occur and also with the heat input. So at this process, fuel can be any type depending on your power plant. It can be biomass, it can be natural gases, coal, and such. So here the process after it's been boiled with the input heat inside and combustion, it will then release as a superheated steam. Okay, it release as a steam at higher temperature and higher pressure. Then after that, this high temperature and pressure of steam will then enter the turbine. So here what turbine will do is that the blade will start rotate because of the higher temperature and pressure of the steam. The blade will rotate and of course it produce output work, and this output work is the one that going into the generator and produce electricity. So when this produce work output, this is where all this most of the work output will go for the electricity generate, but some of it will have to be released. So when it's being released or being exhaust, this high temperature and high pressure of steam after it's going through the turbine, the expansion occur. Of course, the temperature and pressure will reduce, but still is still in terms of steam. So this steam will then enter the condenser. So the function of the condenser is basically to convert from steam becoming a liquid. So here this is where heat is being released. So when the heat is being released, the steam is able to convert from steam to a liquid. So when it's able to convert, this is where the temperature and pressure also is being greatly reduced. So after the pressure and temperature is being greatly reduced, this liquid will then enter the pump. So this is basically the working mechanism where it we consider this as a closed cycle or closed loop for this power plant. So for depending on the cycle, there are quite a number of devices also being inputted. Like you have more turbines being put in, you using a compressor and such, depending on the cycle. So that is the working mechanism basically on the power plant. Um, and actually, this is one of the areas of applications for the thermodynamic. So application for thermodynamic will look into two major things. One is power generation and another one is on the refrigeration. So for power generation, actually we subdivide into two types of cycles, gas cycles and also vapor cycles. And for the refrigeration, we sub into refrigeration cycle. So Inside of gas cycle, it also can be subdivided into quite a number of cycles, right? Otto cycle, diesel cycle, Stirling and Ericsson cycle. So all these are the type of cycle we have in the gas cycles. So our focus would be on the gas cycles because we want to look into Otto cycle and diesel cycle. And example of the gas cycle is the internal combustion engine, which is generally known, and gas turbine is also one of the example of the gas cycle. So overall, we have go through what is power plant, what is the working mechanism of power plant, and what we're going to sub into looking into this presentation or in this webinar in more detail. Okay, to look into reciprocating engine. So reciprocating means it moves forward and backward. So it's reciprocate. So this reciprocating engine actually can be divided into two main engine, which we call as a spark ignition engine, SI engine, and also compression ignition engine. So the major difference between spark ignition and compression ignition is that spark ignition have a spark plug. So the function of spark plug is to ignite the air fuel mixture that being put into. And for the compression ignition engine, it is self-ignite due to the high compression ratio. So when you divide into the spark ignition engine and compression ignition, is actually producing these two cycles, Otto cycle and also diesel cycle. So if we look into the structural diagram of a spark ignition and compression ignition, it's basically start with an inlet valve. Okay, so you have an inlet valve to ensure that the air and fuel mixture are being put in. You have a combustion chamber where combustion take place, and then you also have an exhaust valve in order for the exhaust gas to be transmitted. And of course, the same also applied to the compression ignition engine. You have inlet valve, you have combustion chamber, you have exhaust valve. Now the difference is that here we have spark plug for the spark ignition. So this is where that combustion occur or is ignite. And instead, for the compression ignition, we have injector. So the function of injector is to supply air inside in order for which we compress the air to ensure that combustion taking place. So these are the major difference between spark ignition and compression ignition engine, which Otto cycle represent a petrol engine and diesel cycle represent diesel engine. Okay, let's go through in details on the Otto cycle and diesel cycle first. So Otto cycle, like mentioned just now, is an example of spark ignition reciprocating engine, which developed by Nicholas Otto in 1870. So he's the one that found this, and upon his name is creating this Otto cycle or develop Otto cycle. So in general, SI engine, it has 4 strokes and it's 2 revolution per cycle. Now, this 4 stroke is actually comprised of intake stroke, compression stroke, power stroke, and exhaust stroke. So how does Otto cycle mechanism of the Otto cycle is that just now I mentioned we have inlet valve. So the first step is that when the air fuel mixture is being injected, the inlet valve will start to open and allow this air fuel mixture to enter the chamber. Now, actually we call TDC and BDC, which is top dead center and bottom dead center. This is where when air fuel mixture is being released into valve is open. This is where all this air fuel mixture will then move from TDC to BDC. So this is where intake stroke happen. Now, when all enough air fuel mixture is being released into the chamber, this is when compression stroke start to occur, in which it will start moving from BDC to TDC. So when it moved from BDC to TDC, at this point, this is where pressure start to increase. Okay, because you are being compressed. Compressed means you want to increase the pressure. So this is where pressure will start to increase. Now, after it reach slightly before it reach TDC, this is where spark plug will start to ignite. So it will start to ignite, and also mix with the air fuel mixture. And at this part, this is where combustion start to occur. So when combustion starts to occur, this is where it reach the maximum pressure. So combustion start to occur when the pressure is high, and at the end it produces a higher pressure and higher temperature. And once end of the combustion, this is where power stroke, or we call it as expansion stroke, start to happen. It move from TDC to BDC. So when the expansion start to happen, pressure will start to reduce. So when the pressure start to reduce, this is when it will enter the exhaust stroke. So exhaust stroke um, happen when the exhaust valve is being opened, and all these exhaust gases will start to release. And this is where it will move from BDC to VDC. So when exhaust happen, of course, your volume will decrease because all the exhaust gases are being released. So this is the four strokes happen in the Otto cycle. So you have intake, compression, power, and exhaust. So in general, this is how it moves. So you can see at the start, at the blue one, this is intake valve happen. After that, compression occur, and then power exhaust, and lastly, exhaust stroke. Okay, so the right blue side is the intake port, and the left brown side showing the exhaust port. So when these four stroke happens and there are two revolutions occur, this is make a cycle, which we call as a O2 cycle. Of course, in thermodynamics, we learn, we want to assume that it's become internally reversible. This is where Otto cycle, we name it in these four processes, which is isentropic compression. We have constant volume heat addition, isentropic expansion, and constant volume heat rejection. Just now, that stroke is actual what happening in the Otto cycle. But when we want to do calculation or we want to do simulation, we are actually looking into ideal Otto cycle, which involve these four processes. This is where we have this PV graph of the ideal Otto cycle. Okay, so that's basically in general what is Otto cycle. Moving on to the diesel cycle is actually developed, it's a CI engine developed by German inventor, which is Rudolf Diesel in 1897. It's similar to SI engine, but the things that mentioned just now, it is self-ignite. So when it's self-ignite, air is compressed to a high temperature, which is above the fuel's auto-ignition temperature, in which auto-ignition, we don't want it to occur, meaning that it's ignite by itself or spontaneously ignite. When this happen, it can cause engine knocking and damage your engine. So for CI engine to work, your air must be compressed to a higher temperature, higher than auto-ignition temperature. So the process is similar like what we discussed just now in Otto cycle. It just that now is replaced with fuel injector where air is being compressed. And during the process of combustion in diesel, because it's not lit by spark plug, it's self-ignite. So it take the combustion process take in longer time for the combustion to occur. So at this point, when we want to do simulation, we are actually looking into the process where it become ideal, where just now at the process of heat addition, we assume it become as a constant pressure heat addition. So this is where Otto and diesel cycle differs from each other lah. Okay, so that's overall basically the major difference between Otto cycle and diesel cycle. Now, when we're looking into the gas cycle, actually the invention of this Otto is actually to provide alternative to what steam engine. Steam engine, I mean, from centuries before this, we always heard about what steam engine. So Otto is actually an invention to provide an alternative to it. And also, of course, after that, Rudolf Diesel also come in and patent the CI engine. So the first ICE, actually, the internal combustion engine, actually reached only efficiency level of 10% to 20%. So along the way, engineer make the engine efficient, okay, improve it, and up to now, I believe it's reached 48% for the diesel engine in Finland. And for the petrol engine, it's slightly lower, which is 37%. Okay, and then the major difference, because we are looking into the difference between auto cycle and diesel cycle. So as we have gone through, actually, the major is that we just now that I mentioned is about the spark plugs and self-ignited. But along the way, actually throughout, there are quite a number of difference between auto cycle and diesel cycle. So basically, of course, the working fluid of auto is petrol and diesel is using the diesel. But if we look in a more details, it's actually auto cycle, it have a lower compression ratio. Diesel cycle has a much higher compression ratio. And due to the fact just now that because of the time taken for the combustion, it has constant pressure and also constant volume processes, but auto is only limit to constant volume processes. And for the same compression ratio also, the thermal efficiency of diesel cycle is lower than auto cycle. But if you are looking at the same maximum pressure and temperature, the thermal efficiency of auto is actually lower than diesel. So depending on the conditions of the power plant itself or the conditions of the engine itself. And of course, due to the compression ratio, auto cycle, the petrol engine is actually light in weight compared to the diesel. So overall, this is throughout the major difference between auto and diesel. So when we want to apply it for a power plant, basically you need to look into the thermal efficiency. The working principle of the gas cycle is important to look into its thermal efficiency, because as an engineer, that is what you want to achieve, you want to improve. But of course, when you are working in this bigger plant, the economics also need to be considered, because each of the improvement that you make, it's come with a great cost. So the economics of power generation itself need to be considered, whether is it relevant with this cost to get this thermal efficiency. So in all, for the same compression ratio, auto cycle is more efficient than the diesel cycle. In the same maximum pressure and temperature, the diesel cycle is more efficient than the auto cycle. So let's say after this you are working in a power plant, at least take this all these factor into consideration as an engineer, because as an engineer you are a problem solver, so you can look into this, especially when you are working in power plant or related to that. Okay, I think that will be all. I think that will be all for today's presentation. Thank you so much for the time.
Okay, thank you very much for your presentations. I hope you all enjoy these amazing presentations. Okay, now Miss Hafiza will answer some questions that were sent to us during the presentations. So the first question is, I will read for you, okay? Okay. Uh, what is the challenge that you facing when dealing with the auto and diesel cycle, and which one is the more challenge? In your opinion, which one is more challenge between auto and diesel?
Sorry,
Oh,
can
sorry. Oh,
you
you can
repeat
hear.
again?
Oh,
Oh yeah,
okay.
yes.
Sorry, sorry. Okay.
Yeah, it
Okay.
was
What?
breaking, so sorry.
Oh, okay. Sorry. Okay. What are the most challenge that you are facing when dealing with the auto and diesel cycles? So the challenges that you are facing.
Okay, so if looking back into my research, mostly I deal with diesel, but I think the challenges when we look into the auto cycle and diesel cycle, of course, in terms of power plant, you want to look into the thermal efficiency and also the cost. But I think then now we are also looking into sustainability. So when we are looking into the sustainability, and also we don't want pollutions to occur and all that, we also need to look into the soot particles that are going to be generated and all those. So I think all in all, many factors need to be taken into account when we want to work into auto or diesel, because of course you want to look into for the environment, because the soot particles that made by diesel engine is quite huge. And also you also want to look into the cycles itself, because each of it, any improvement that being made, need also come with a cost. So I think basically that will be the challenges when we want to look into the cycles.
Okay, thank you again for answering those questions. Okay, first of all, we would like to thanks for the great presentations. It was a pleasure to have you with us. So this concludes our webinar sessions. Thank you all for attending. We hope you have learned and enjoyed these presentations as much as you can. Hopefully, the presentations was beneficial for everyone. On behalf of Masa University, we would like to thank you for joining us today. Thank you for your time and cooperation. So we will end our webinar sessions for today. Thank you. Goodbye and see you
Thank you
again.
also, Master University.
Thank you, Ms. Afiza, for coming and for giving the good presentation. Okay, we'll see you again. Thank
Thank you,
you. Bye.
Doctor. Okay, bye bye.
Bye.